Hi everybody, I'm sorry I couldn't be here today. Today I'm doing textbook adoption work for the county so that hopefully next year we'll all have really good textbooks for when this new curriculum rolls out. Okay, so let's talk a little bit about what we're doing today. Today we're going to be doing something called adding and subtracting rationals. Now yesterday you all simplified rationals. Today you're adding and subtracting them. So what you want to do is we're going to have to kind of think back, how do fractions work? So here's kind of our Wayback Machine kind of a thing. So if I want to add these two fractions, the first thing I'm going to do is I am not just going to add the numerator and the denominator and come up with 5/7. Why? Because that's wrong. So what I have to do is I have to find a common denominator. Now, over here on the side, LCD, that stands for least common denominator. So if I think about, let me scoot over so it's least common denominator. So if I think about these things, I've got a 4 and a 3, and the smallest number that both 4 and 3 can divide into is 12. So in order to make that denominator a 12, I will need to multiply the top and the bottom of the fraction by 3. So 9/12 is the same thing as 3/4 if you were to simplify it. Over here on this side, I need this to be a 12 also. So I'm going to multiply by 4 on the top and the bottom. So that becomes 8/12. Now, once the denominators are the same, you're allowed to add those together and you get 17/12. So that's what we're going to be doing today, is we're going to be adding different problems with like denominators. Sometimes they're already going to have like denominators, sometimes they're not. So the other little thing that's over here is called the least common multiple. And we won't be using that as much today, but we will be using that least common denominator a lot. So let's slide on down to our first two examples. Now these two examples have common denominators. So if they have common denominators, see, look, they both have an x plus 4 and they both have an x minus 6. That means that you're just able to add the numerators together. So I can effectively rewrite this as x plus 4 over x minus 6. And so I'll have x squared minus 8x minus 1 plus 3x minus 5. So notice how I just put those together. And now, in order to finish this problem, I need to combine my like terms that are in my numerator. I'm not going to multiply out my denominator because I have found over the years that that doesn't help me. And a lot of times I just have to go back and remultiply it or refactor it. So it's always better to leave your denominator factored. Your numerator, you just want to combine your like terms. Okay, so kind of run out of room over here, so let me grab my extra sheet of paper. Right over there. Okay, so I mentioned not to remultiply your denominator. And the reason for that is because a lot of times we're going to end up factoring our numerator and taking out, reducing, simplifying common factors. So if I continue onward with this problem, I'll have x minus 6 and x plus 1. And for those of you who just got lost, like what the heck just happened, I factored it using the AC method. So I'm looking for factors of -6 that add up to be -5, and those are -6 and +1. Okay. Now notice all I've done here on the bottom is I just changed the order, but if you didn't change the order, that's okay. You'll notice you have a common factor on the top and the bottom. So your final answer on this is x plus 1 over x plus 4. Done. That's what your goal is. You want to combine your like terms, then factor your numerator if possible. It may not be factorable. And if you have a common factor, cross it out. Now, when you're thinking about those common factors, what is that coming from? That's like if you had something that was divisible by 5 on the top of your fraction and 5 on the bottom. You want to get that extra stuff out. All right, now pause it there if you need to. Back it up if you need to do it again. Let's go look at the second problem. So again, this one already has a common denominator. So I am just going to go straight across and I'm going to put these terms together. Now I know there are a few people who just went, whoa, why did all the signs change? Because it's minus the numerator, so I have to change all those signs, kind of distribute them. Then I'm going to put my like terms together. No, you don't have to write the 1 on the x. Okay, now I've said it a bunch of times, and I know that there's some of you who are paying attention, some of you aren't. Don't try and factor if your number is negative in front of your squared term. So if you're trying to factor this, you need to start by pulling out your negative that was in front of your squared term. No, you don't have to write that 1. Okay, so I've kind of run out of paper, so I'm going over here on the side. Got a little extra paper on here. Okay, so now I have a little more room. So up here again, I'm going to use the AC method. So that's 1 times -6. So factors of -6 that add up to 1. How about x plus 3 and x minus 2? Just like that. And you'll notice you have exactly the same factor in the top and the bottom. By the way, don't just cross out the x, cross out the plus, and cross out the 3. It's got to all go together. The whole factor's got to go at once. So your final answer is x minus 2. Yeah, I'm scooting it over. And that's your final answer. Okay, so far we've seen 2 problems where they had like denominators. Let's go take a look at some that don't have like denominators, because this is always where it gets a little challenging. Now I'm going to rewrite this problem over just so I have plenty of room and I don't have to write really small. Okay. So I look at my 2 denominators and you'll notice they're not the same. Now they both have a 5, but this one doesn't have an x over here on the right. So I'm going to multiply the top and the bottom by x, so it will have an x. Yes, you're allowed to do that because x divided by x is just, well, it's 1, and so it goes away. Okay, so now they have common denominators. So now I'm allowed to put these together. Just like that. Now, the top's not in standard form, so I'm going to put it in standard form. Okay, now on all the previous problems, I was able to factor and cancel stuff out. Now, your bottom is already technically factored because factors mean things that are multiplied together. Well, 5 and x are multiplied together, so they are factored. Even though they don't have parentheses, they're factored. On the top, I can factor a 2 out. And unfortunately, there's nothing that crosses out. I can't cross out the 2 with the 5. There's no 4x plus 1 on the bottom. So this is my final answer. Now, if you'd like to leave it in factored form, which is what I normally do, that's where you leave it. If you want to leave it in unfactored form, just go back a step and circle that answer. So hopefully that's okay. Let's try problem C. Okay, so I'm going to rewrite C over because I like having a little bit more room. than are allowed in the notes. Okay. So I need to have a common denominator. Now, fortunately, my x's match the gray, but the 16 and the 12 don't match. So just kind of to remind you, this is 3 times 2 times 2, and this is 2 times 2 times 2 times 2. So in order to get these denominators to match, this piece over here is going to need a times 3. And this piece over here is going to need a couple more 2's, so 4. So the number that I'm going to be looking for in this case is going to be 48. So 48 is a number that 16 and 12 will both divide evenly into. So by writing the little factors down here on the bottom, it lets me know what's missing. So I need my common denominator to share common factors. So here's what I've got to put into it. So this side over here needs 2 more 2's. And whatever I do to the bottom, I got to do to the top. And this side over here needs a 3 so that they will both have 4 2's and a 3. And whatever I do to the top, I got to do the bottom. Now, normally, I don't write this out in this much detail, but I wanted you to see it because you really can't ask a lot of questions. So I've got 88 over 48x squared plus 45 over 48x squared. Now, don't reduce your fraction here. At this point, you want to combine like terms. So I have seen more than a number of kids sit there and go, oh, I can divide the top and the bottom by 8. Well, guess what? If you do that, you go back where you started. You got to redo what you just did. So instead, we're going to put them together. Of course, add your numerators together. So let's see, 12, so it'll be 1, looks like 33. Yep, 133 over 48x squared. Now, let's talk about this. So the bottom down here, that divides by 2's and 3's. Up here on the top, that is not divisible by 3 or 2. So that means that is your final answer. So again, check to see if 133 and 48 will divide evenly by something and simplify. If they won't, you're finished. Like, that's it. That's done. Done. Okay, let's slide on down to D. By the way, as soon as you get the hang of what we're doing, you don't have to keep doing problems. I would hang out together with me until at least E, just to make sure you've got an idea of what's going on. But if you find that you don't need any additional examples after E, I completely understand. Okay, so let's talk about these parentheses. They are absolutely not necessary. I just put them on there so they'd be the same. Remember that factors are things that are multiplied, not added or subtracted together. So this is a factor in its entirety, and this is a factor in its entirety. So if I look at these two problems, the left side needs an x minus 3, and the right side needs an x plus 2. Now, if all you do is do that, you will not have a common denominator. Well, I mean, you'll have a common denominator, but your numerator isn't right. So remember, you got to multiply the top by the same thing. So you'll notice I'm doing the same thing on the top and the bottom. Now, on the top, I'm going to multiply that out just so I'll be able to combine like terms. On the bottom, I am not going to FOIL that together. And you'll see this over and over again. I leave my denominators factored. Factored means it's got parentheses in it. It's things multiplied together. That's how we're going to leave it. Now on the top, we are going to have to distribute. Because if we don't do that, we really won't be able to combine like terms. Now when you distribute that, because of the minus, distribute it as a negative 4x. Okay, put everything into standard form, combine your like terms. Oh, that's a 3. Okay, so I don't know if my numerator factors, but I do know that I'm not going to attempt to factor anything if I have a number in front of my squared term. And by the way, I notice all these divide by 4, so I'm going to factor a negative 4 out. Okay, so let's talk factoring. Please notice I still have not multiplied my denominator together. All right, so if I'm doing AC method, I'm looking for factors of 9 that add up to be negative 1. So I'm going to have a negative 1 and a negative 9, a positive 1 and a positive 9, a negative 3 and a negative 3, or a positive 3 and a positive 3. None of those work, which means this is as factored as it gets. It is factored. You have a negative 4 out front. That's a multiplier. It's negative 4 times the parenthesis. You are done. There's nothing to cross out, nothing to simplify. That's it. You're finished. Okay, let's move on to E. Oops, sorry. Let's move on over here and let's do example E. E, not 5. Okay, I'm going to recopy it. Again, I just like having a lot more space to work. Okay, so this is the first one we've encountered where the denominator is not factored for us. So we do need to factor that. So I'm going to use the AC method. So I'm looking at factors of negative 15 that add up to be negative 2. So that would be x. Let's see here. That'd be minus 5 and x plus 3. Over here, that's difference of squares. So that's x minus 3, x plus 3. So right now, I've got x over x minus 5 and x plus 3. And I've got 3 over x minus 3, x plus 3. Okay, so for these denominators to match, they must have these same factors in them. These both have an x plus 3, but this one has an x minus 3 that doesn't appear on this side, and this one has an x minus 5 that doesn't appear on this side. So I need to get that to match. Okay, and over here I've got an x minus 5 that need to match. Now whatever I do to the bottom, I have to also do to the top. Now on the bottom, I am going to leave that completely factored, like done, factored. So I'm not going to FOIL it out or get out the box method or whatever it is. I'm not going to do it. Now on the top, that's a whole different story. In order to combine these parentheses together effectively, you have to distribute. Again, not going to not going to FOIL out my denominator. By the way, the order on these terms doesn't matter. They're all multiplied. You can multiply in any order, so you can leave them in the order they're in right now. Distribute. Okay, so I've gotten to here. Now at this point, my denominators match, so that means I can write my denominator one time and put my pieces together. So that's a minus 3x, that's a plus 3x. So I've got x squared minus 15 over x minus 5, x plus 3, and x minus 3. Now let's see if my numerator factors. That is a perfect square. That is a minus. That is not a perfect square. That is a perfect square. That is a minus. That is a perfect square. That is not a perfect square. So that means this is my final answer. If you would like to FOIL together the denominator and distribute, you are welcome to, but no one expects you to do that. All right, so I know some of you will be leaving me at this point to go work problems, but I know a few of you would like to see a little bit more, so let's head on down to F. And again, give me just a moment to recopy because I like having the extra space. Okay, so I have to have a common denominator. So here's what I know has to happen. All of these have to have a 3 in them. All of these have to have an x cubed in them. All of them have to have a 5 in them. And all of them have to have a y in them. Okay? Just remember the x cubed, and I'm going to kind of write out for you x, x, x. So they all have to have the same number and type of everything. So let's talk about what this one is missing. This one does not have a 5 in it. This one also needs 2 more x's, so it'll match up with the x cubed, and it needs a y. Okay, this one over here doesn't have a 5 or a 3, so I'm just going to call it 15 to save a little space. Let's see here. This one has the 3 x's, but it needs a y. Okay. Over here, this one needs a 3. It has 1 x, so it needs 2 more x's, and it has the y. Okay, so take a look at what you have here. The 5 and the 3 are there, 3 x's and a y. 5 and 3, 3 x's and a y. 5 and 3, 3 x's with a y in the middle, but 3 x's. Okay, so on the bottom, this is not like when we have the parentheses. I'm going to kind of put everything together. So down here on the bottom, I have 15 x cubed y. Now you'll notice I did not do that when I had problems that had parentheses, but these don't have any parentheses. So you certainly should feel very comfortable doing that. Okay, let me give everybody just a moment to get that. Okay, so now let's talk about our top. We have 20 x squared y. Please do not start reducing this fraction. We have 120 y, and we have 6x squared. Now that they all have common denominators, we can write them together in a single fraction. So I've got 20 x squared y. I've got 120 y. I've got 6x squared. None of those have matching denominator, or sorry, none of the, well, they all have matching denominators, but none of them are matching like terms, so I can't put them together. I am going to change the order a little bit because I think I'd like to have the x squared term comes first. If you wanted, you could have it second after the 20 with the x squared y, but I like just having that kind of solo term there by myself. There's not a really super clear standard form on this, so there's a lot of flexibility, but I just felt like I liked having my 2 x squareds together and then my 2 y terms together. Okay, do not start weirdly crossing out stuff with the denominator because that will undo all of the beautiful work you just did to get this exciting, gorgeous problem answer. All right, there's one last problem. Let's take a look at it. Ooh, this one's a doozy. Okay. Woo, wow, that's some excitement there. All right, so I'm going to start with just the numerator. So I'm not going to even look at this denominator for a moment. I'm just going to look at the numerator. Now, right now, this has a denominator of 1, and I really need those to be common denominators. Like, I need them to be the same. So if you want to, you can say, all right, I'm going to multiply this side by 1 and this times 1, but multiplying by 1 really doesn't make a difference. On the other hand, multiplying by x does. So again, I'm just looking at the numerator because I don't want you to get overwhelmed. That'll be 3 over x plus 4x over x. So that becomes 3 plus 4x over x. And that becomes, I'm just going to slide a little bit here. I like it in standard form. 4x plus 3 over x. All right, so that's just your numerator. I'm going to give you a chance here. If you need to pause it so you can write that down. Now, I'm going to slide on down at this point, and I'm going to look at my denominator, and only my denominator. Notice I'm covering up the numerator because I don't want to look at it. Okay, so right now my denominator is 1. Okay, that's what I currently have right now, 1. So I need this to be a common denominator. So, of course, I can multiply this by 1 and this by 1. It doesn't make a difference, but multiplying by x does. So this will become x plus 4 over x minus 4x over x, which I'm going to put all this together. I'm going to have x for the denominator, and I'm going to have x plus 4 minus 4x. Again, kind of putting it together. That's negative 3x plus 4 over x. So that's from beginning to end on that. Okay, now let's put it all together. Whoa, that's a lot. So what I want you to notice on this is that your numerator and denominator, both have an x in the bottom. So if you use the rules for multiplying and dividing fractions, that x is going to cancel out. Let me show you why if you need to see it. So technically, this is what you have right over here at the end. This is what you have. Divided by negative 3x plus 4 over x. Now, what you should remember from middle school is that if you are dividing two fractions, you are going to change your division sign to multiplication and flip or take the reciprocal of your second term. Some teachers taught that as keep, change, flip. Keep, change, flip. So keep your original fraction, change your sign to multiplication, flip or take the reciprocal of the second term. Now what happens there is, remember you're able to reduce or simplify at a diagonal. So this goes away and this goes away, and you end up with 4x plus 3 over negative 3x plus 4. Now do not start going crazy and crossing out the 3 and the 4. No. When you're doing this, the entire factor has to go with an entire factor. And while those have similar numbers, they're not the same. So this is your final answer. And that's kind of it. So those are all the examples. Let me summarize your process down here for you. So number 1, get common denominators. Second, add or subtract the numerator. Three, factor the numerator if possible. And then finally 4, reduce, not reduce common factors. And that's kind of it. Now, I have put your answer key for 8.1 out on Teams. So watch this video, and then I want you to do problems. Now, I know there's a lot of them, but I also know that the more of these you practice, the better you are going to be at this. Please do not do number 1 and number 3. Go on down here and do 5, which is simplify the expression. And what they mean by that is get common denominators and add. Down here, you're finding the perimeter. Remember, perimeter means add up the sides. So that means you're going to have to get common denominators and add. Here's some problems just like that last one we did in our notes. And then here's some more where, again, you're going to get common denominators and you're going to add. I will tell you right now that I will be looking to see if you did factors or not. So like when you get down to this problem, if you do not factor that denominator first to get common denominators, you are not going to get the right answer. All right, that's kind of it for today. Hopefully things will go super well for you and you will not have any issues.